Good morning. This is the last video for section 2.4, and which is officially the chain rule. Now we're talking about some kind of last new derivatives here of some more exponential functions and logarithmic functions, and how to take their derivatives and how to use the chain rule to do that. So here we go. All right, we know these derivatives already, that the derivative of e to the x is itself. Again, we have to be on the lookout for easy derivatives, and that's as easy as they get, that the derivative of e to the x is itself. And then this one over here, all it does, that's just the chain rule. The derivative of e to the anything, e to the u, where u is some function of x. So the derivative of e to the u is e to the u, so it still starts with itself. But then the chain rule says times the derivative of the inside. So really the inside function here is the exponent. The outside function is e to the something. So the derivative of e to the something is e to the something. But then the chain rule says times the derivative of the inside, which here is the exponent, which here is u prime. So the derivative of e to the u is e to the u times u prime. So here's just two quick examples. This one is this one over here on the left. That's an e to the u. My function of x happens to be negative x. So the derivative of that would be, it's always itself, e to the negative x, and then times the derivative of the inside. The derivative of negative x would be negative 1. And again, that doesn't say minus 1. It says times negative 1. So you'd probably write this as negative e to the negative x. Good enough. The second one you have to recognize is a product rule. There's my first, there's my second. Gotta be real careful not to forget, even though there's a chain rule in there, it's ultimately, or at least initially, a product. So the derivative of a product is the first times the derivative of the second. The derivative of the second, well, there's my new e to the u. The derivative of e to the something is e to the something. That's a 2, sorry. And then times the derivative of the inside. The derivative of x squared is 2x. So far I have the first times the derivative of the second plus the second, which is e to the x squared, times the derivative of the first, and the derivative of 3x cubed is what, 9x squared. So again, you have to recognize this as first derivative of the second plus second derivative of the first. And as far as cleaning these up is concerned, let's look for a GCF. Again, the plus sign in the middle being separating the two terms, it appears that both terms have an e to the x squared. So that's certainly part of my GCF. What else do both terms have? They both have a 3 and an x squared, I think. So I think all of that is my GCF. Now I've got something plus something. I'm taking out a 3x squared and an e to the x squared. So to the left of the plus sign, if I take out a 3x squared and e to the x squared, I have a 2x and another x. I believe I have 2x squared left. Make sure that's right. I see a 3x to the third, x to the fourth, okay. And then to the right of the plus sign, I take out a 3x squared and e to the x squared. I think it's just 3. I don't think that cleans up anymore. If there are any negative exponents, I'd move them to the bottom. There aren't, so that's absolutely done. So derivative of e to the x and e to the u. Okay, next. What if the base is not e? So instead of e to the x, like it's 2 to the x, or 3 to the x, or 7 to the x, still an exponential function. So you'll notice how this is very similar. The derivative of a to the x is still a to the x, but then times the natural log of a, which is the natural log of the base, which is going to be like the natural log of 3 is some decimal. It doesn't matter what it is. Let me remind you that where we just were, like if it was e to the x, it would just be the derivative of e to the x was just itself. We wouldn't put times the natural log of the base, but if we did, the natural log of e is just 1. So really, it's almost like we've been doing that. We haven't needed it because the natural log of the base e happens to be 1. But here the natural log of another number is not 1. So this one down here is just a straightforward, if y equals 5 to the x, the derivative of 5 to the x is still 5 to the x, and then times the natural log of 5. And that doesn't clean up any. Enough. And then on the right here, if it's the derivative of the natural log of u, I lied, it's a derivative of a to the u, like 3 to the u, or in this example, 7 to the u, it's still a to the u, like these, they always start with themselves, and then times the natural log of the base still, which is what we just talked about. And then because of the chain rule, because that u is a function of x, the chain rule says multiply it by u prime at the end. So it's a to the u times natural log of a times u prime. Easy to forget one of those three pieces. So this example down here where f of x equals 7 to the x squared. So the derivative of that, three pieces. It is itself 7 to the x squared times the natural log of the base, which is the natural log of 7, times the derivative of u. The derivative of x squared is 2x. And you can absolutely be done here. That's perfect. Do not write the natural log of 14x. That is tempting but wrong. It's a natural log of 7 times 2x. So we're just going to leave it like that. The derivatives don't clean up very much. But the derivative of a to the u is a to the u times the natural log of a times u prime. All right, next. Now, what about now let's talk about taking the derivatives of logarithms. And again, good news, these are fairly straightforward. We have two different types here. We have derivatives of natural logs, which is the log base e, and then we have derivatives of other logs, like log base 10 or log base 5 or log base 3. So this page is about the derivative of natural log. And in its most basic form, we like these derivatives. The derivative of the natural log of x is 1 over x. It's that easy. And then the derivative of the natural log of u, if it's the natural log of a function of x, well, starts the same. It's the that. Really, this is the chain rule. Inside function is u, some function of x. Outside function is the natural log of something. So the derivative of the natural log of something is 1 over that something. That's that part right there. And then the chain rule says times the derivative of the inside, which in this case would be u prime. So notice that I have these two forms here, 1 over u times u prime, which I could write as u prime over u. Those are absolutely interchangeable. I always tend to write it first as 1 over u times u prime, but certainly I could put the u prime on the top of the fraction. So here's two examples of natural log of u. So the derivative of the natural log of 7x is 1 over 7x times the derivative of 7x, which is 7. And you'll notice the 7s, I could write this as 7 over 7x. 7's actually canceled. Just end up with 1 over x. Turns out that that's just 1 over x. And actually, in the next slide, we're going to start talking about rules of logarithms, which that would even make more sense. But there it is, just 1 over u times u prime. And then this one to the right here, y prime, the derivative of the natural log of u is 1 over u, which is 1 over 3x squared plus 7, times the derivative of the inside, which is what, 6x? And it would be completely valid to write it like that. If you'd rather write it as 6x over 3x squared plus 7, also fine. So the derivative of the natural log of u is 1 over u. Let me go here for a second. Sorry about that. Okay, sorry about that. I had to check something real quick. Okay, so that's the derivative of the natural log of u. All right. Now, here's an example. Well, let's talk about how we would have to do this example. Then we're going to talk about a shortcut or an easy way. If we didn't know any better, we would do this. And I'm going to start this, then I'm going to stop it because there's an easier way. The derivative of the natural log of something. And this is something. So it would be 1 over the whole thing times the derivative of that whole thing. And that whole thing is a chain rule. So it would be 4 times that whole thing to the third. And then I would have to take the derivative of the inside, which would be a quotient rule. Like they get really ugly. When you're taking the derivative of the log of a complicated function, if you just use what we just learned, the derivative of the natural log of u is 1 over u times u prime, it gets ugly. So the good news is we have properties of logs that you learned in either an Algebra 2 or a pre-calc class. I'm going to remind you of them, but we can rewrite the original function and make it a much easier derivative. So real quick review of the 3 rules of logs you need to know. Here they are. They should at least look familiar. Rule 1 says the natural log of a product is the sum of the log. Log of AB equals log of A plus log of B. Rule 2 says the log of a quotient equals the difference of the logs. That the log of A over B equals log of A minus log of B. And the third rule says if I have an exponent, the log of A to the B, I can move the exponent in front of the log, B times the log of A. And it works with any base, natural log, log base 10, 3, whatever. So there's 3 rules of logs. Okay, so let's go back to this same problem and realize if we rewrite it first using these rules of logs, it is a much easier derivative to take. So there's that same problem. And first I'm going to move the 4 out front because the natural log of A to the B, I can move the B out front. So now it looks like that. All I did was move the exponent out front. And now I've got the log of a quotient, which according to the rule is the difference of the logs. Notice that the 4 goes to both these. So now I'm rewriting it like that. I've not done any calculus yet. I moved the exponent out front. I wrote it as the log of 2x minus the log of x squared minus 3x, the 4 getting attached to both of them. Now, I think that's all I wrote on here. Now I actually have to do the math. Now I can one piece at a time much more easily take the derivative. So now let's take the derivative of this. F prime of x. The derivative of 4 natural log of 2x. So that'd be 4 times the natural log of something is 1 over that something, and then times the derivative of the inside, and the derivative of 2x is 2. I think there's the first one. And the second one is I have just a 4. That's just a constant, the constant multiple rule, just bringing that forward. And then times the derivative of the natural log of something is 1 over that something, x squared minus 3x. And then the chain rule says times the derivative of the inside, and the derivative of x squared minus 3x is what? 2x minus 3. How can I clean this up? Let's see here. I think this whole thing in green here, I got 8, 4. Is that 4 over x, I believe? And then, excuse me, minus 4 times 2x minus 3 over x squared minus 3x. I gotta be careful. I didn't mean to, that fraction line ends right there. Okay, so that's a much easier derivative to take using rules of logs. When you're taking the derivatives of log functions, be on the lookout for rewriting them. Now, I'm going to go back to this first simple, this one, where we got just 1 over x. No, not that one, sorry. Natural log of 7x. That was not a difficult log to take, derivative to take. 1 over 7x times 7. But now that we know that we can use, so is the f of x equals the natural log of 7x. Well, we already did it this way. F prime equals 1 over 7x times 7, which was just 1 over x. That wasn't difficult. If I use rules of logs, I can write this as the natural log of 7 plus the natural log of x. That's just rewriting the function. That's not the derivative. And now if I take the derivative, well, the derivative of the natural log of 7, the natural log of 7 is a constant, so that's just 0. So it's just 1 over x. So I kind of got there either way. All right, last thing in this section is what if the base is other than a? And these formulas you just kind of need to know. They look more confusing than they are. So here we have the derivative of the log base a of x, not the natural log. So instead of just 1 over x, which is what it was when it was natural log, it's 1 over x times the natural log of a. So again, we just need this piece in the bottom. And if the base happened to be e, the natural log of e is 1, which is why we didn't need that on the last slide. So the derivative of the log base a of x is 1 over x natural log of a. Just gonna have to know that. And then, we have a typo here. This is a 1, not an I. And then over here, if the log base a of a function of x, the log base a of u, now we're looking at this one, it's still 1 over u, whatever u is, and we still need that natural log of a there on the bottom next to the u. 1 over u natural log of a. But then the chain rule says we still need to multiply it by the derivative on the inside, which is that u prime. And again, you want to move the u prime on top and write it like u prime over u natural log of a. That's fine. So derivative of the log base a of x is 1 over x natural log of a. The derivative of the derivative of the log base a of u is u prime over u natural log of a. And then as just one example, here's the last function we'll take the derivative of. So that's the log base a of u, because it's the log base, other than e, 7 in this case, of a function of x. So the derivative would be 1 over u natural log of a. U is the 4x minus 2, and then times the natural log of the base, which is 7, and then times the derivative of the inside. Well, the derivative of inside is just 4, so I could put that 4 out there, or it is equally as right, just in this case, since it's 1 up there, I'll just make that a 4 and be done. There it is. We got the derivative of e to the x and a to the x and e to the u and a to the u and the natural log of x and the natural log of u and the log base a of x and the log base a of u. Formulas, once you have them memorized, aren't tragically difficult to use. So that's it for this. There's your last assignment in section 2.4. Again, there will be a quiz on Monday on 2.3 and 2.4, product rule, chain rule, quotient rule. Have a great Wednesday.